have two new products we're introducing at the show. One is a major advance in our EDS technology. We've taken our ultra-dry detector and we've improved the energy resolution, taken about 10 eV off of that historical energy resolution down to 123 eV. And we've also introduced large area detectors. So we've gone from the traditional 10 millimeter square detector and 30 millimeter square detector into a 60 millimeter square and 100 millimeter square detector. And the big advantage there is larger active area, larger collection rate, picking up more X-rays. So those scientists like to do large maps, million pixel maps, diverse samples with a lot of elements in them. It takes a lot of X-ray counts to really fully characterize and quantify that sample. You're covering a lot of space. So with a 10 millimeter square detector, this is something that could take 45 minutes, maybe an hour. With a 100 millimeter square detector, it takes 1/10 the time. And the other nice thing is we allow two EDS detectors pointing at the sample on the same microscope at the same time, which then goes ahead and doubles that. So a single 100 millimeter square detector can collect 1 million X-rays per second, storing 300,000 elemental identifications a second. Two detectors, of course now we're doubling the area and doubling the effective detector. The other major advance is our EBSD Quasar. We've added a 4-scatter detector and the ability to go ahead and re-index the crystal structure offline in a much more powerful way. So what the 4-scatter detector allows is when you're tilted at 70 degrees in the typical EBSD data collection mode, you're not going to get great imaging from your backscatter or secondary electron detector. You get very, very fine, very, very high resolution premium imaging with the 4-scatter detector, which gives you a great look at the grain structure and other fine areas that you're going to want to go ahead and investigate, and really guides the scientist during the backscatter diffraction process. The re-indexing, most customers, they go through, they collect the data, and they find a problem after the fact. They want to go back and correct that problem. Our re-indexing allows them to do that. And not only do we allow you to go back and re-index the crystal you looked at, we actually go all the way back to the raw camera images. So we give that scientist the same touch and feel as if they're still on the microscope collecting data, even though they're back at their desk analyzing the data. So any mistake that was made, any setup error, choosing the wrong crystal, redoing your background correction, redoing your spline correction, all that's enabled. So it really gives full capability to the scientist, lower risk, you never have to go back to the microscope. Well, typically EBSD, biggest thing is in metallurgy, fatigue analysis, strain analysis, some novel and unique stuff in ceramics and geology. The larger area detectors can be used in many areas. One big area is where you need a lot of data, but you want very, very fine spatial resolution. So if you take your electron microscope and tune that voltage down to about 3 kV and work at a lower current, you can get EDS spatial resolution below 100 nanometers. Up at typical operating conditions, spatial resolution is 2 to 3 microns. The problem with going down to 3 kV is that you lose a lot of X-ray counts. You orders of magnitude reduce the X-ray emission from the sample. With 200 square detectors in there though, you'll actually collect data faster than you would in normal operating conditions. So the answer is very, very fine, sub-100 nanometer spatial resolution at a very high collection rate.